Everyone, welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 38 is on the screen. Let's get started, please. So numbers 1 and 2 are a review of stuff that you did in the past. Number 3, you should be able to do by yourself. Number 5, you should be able to graph that. And number 4, I'm going to go over that factoring in case you forgot how to do factoring by grouping. All right? So I'll give you guys some time. Copy and go. Okay, we good? You're not good? I am. I'm rocking and rolling. Yeah, I get here extra early just so I can be ready for the day and not have anything that's going to trip me out throughout the day. You know what I'm saying? Like some of y'all need to be waking up like 5 or 10 minutes earlier. You know what I'm saying? All right, here we go. Just a reminder, this session is being recorded. Let's go with number 1. It says simplify. What do you guys notice between the two parentheses? A minus. That is correct. So we need to take that negative and distribute to the parentheses to the right. So that becomes negative 5x to the 4th, negative 10x to the 3rd, negative 9. And then bring down whatever's on the first parentheses, 3x to the 4th, and negative x cubed. So far so good, yes? From there, all we have to do is combine like terms, but start with the highest degree. What is the highest degree? Well, which exponent has the highest power? The 4th degree. So let's combine this one with this one. What is negative 5 plus 3? Negative 2, Mr. Q. Negative 2x to the 4th. From there we go to the 3rd power. We got negative x cubed and negative 10x cubed. So that gives us negative 11x cubed. And last but not least, bring down the negative 9 and we are done. Is that ringing a bell for some of you? Yes? Some are like, oh yeah, we love these. All right. Next. This one is one that got you guys tripped out when you guys covered this with your other teachers. For these kind, I like it's multiplication. I like using a rectangle to keep organized. So I'm going to do that. Sketch a rectangle. I'm going to write the biggest polynomial on top. So I'm going to write 2x cubed, negative 3x, and positive 5, and draw a line down where the first term finishes and where the second term finishes. Next, I'm going to copy the binomial on the side. I got 4x and negative 2. I'm going to draw a line across where the first term ends. The first term ends here. This is called the area model. I'm pretty sure you're familiar with it. If you're not, students area model students. Here we go. I'm going to start at the top. So I'm going to start with this one times these 3. All right, here we go. What is 4 times 2? That's 8. What is x times x cubed? X to the 4th. Next, and we're doing this one together, yes? All right. Let's see. What is 4 times negative 3? Negative 12. What is x times x? X squared. Next, what is 4 times 5? That's positive 20. And then it has an x, so bring down the x. There it is. So we're done with the first term. Let's go to the second term. Now this one. Same thing times all these 3. So here we go. What is negative 2 times 2? That's negative 4, and bring down the x cubed. Next, what is negative 2 times negative 3? Positive 6, and bring down the x. What is negative 2 times 5? That's negative 10. We're almost done. Start with the highest degree. Look inside the rectangle. Which one has the highest degree? This one, so we bring it down because there's no other. What would be my next degree? The third. Is there another third degree? No, so I write negative 4x cubed. What's my next one? The second. Is there another second degree? No, negative 12x squared. First degree. This one and this one. Can we combine these? Yes. What is 20 plus 6? 26x. And then at the end, bring down the 10, and we are done. Whew. Love these. Number 3, you should have done already. Check with your neighbor, see what they got for number 3. Factors for number 3. Let's see, looks like Gio's already done with number 3. But since it's Monday, I'm going to go over this one. What is GCF, guys, for number 3? 4, that leaves us with x squared minus 5x plus 6. However, inside of the parentheses, the 6 and negative 5. What two numbers multiply give me positive 6? That when I add them, give us negative 5. Negative 2 and negative 3. So my factors are 4, x minus 2, x minus 3. We good? All right. I'm going to zoom out, and I'm going to go to number 4. Number 4 is a little bit challenging, but I hope you remember that from other years. Here it goes. Whenever you have something like this, guys, 4 terms, we cannot use the we can only use this if it's a trinomial. So what do you do when you have 4 terms? Well, first, check to see if it's in standard form or from highest to lowest degree. 4th degree, 3rd degree, 1st degree, 0th degree, yes. Second, group in pairs. Group the first 2, group the second 2. And since it's not multiplication, it's addition throughout or subtraction, put a little plus sign right there at top. And then we start and look at this one. Say, what is GCF for this one? Well, they can both be divided by 27. And both of them have x cubed at least. So if we took out the 27 and x cubed, that leaves us with x. 54 divided by 27, that's 2, and we took out the x cubed. Next, what can we divide both terms by? 64, and they're both negative, so it's negative 64 on my GCF. So that leaves me with x. Negative 128 divided by negative 64, that's positive 2. From there, question, what's the same here and here? X plus 2. So if we took this one and this one to make that, what's left over? This and that. So my other factor is 27x cubed negative 64. I'm going to stop right there. We can break this one down a little bit more, but we'll do that later. I'm just trying to get you guys at least to get a couple of factors. And last but not least, graph. So do me a favor, turn to your neighbor. Let them know what values do I use for x to graph any function. What values did I ask you to use for x to graph any function? All right, looks like Jaime's got it. Very good, Jaime. Jacob's got it. I see you, Jacob. So right away, you make a table and use the values negative 2, negative 1, 0, 1, and 2. All right? So then I'm going to use this function, f 1 over blank. My first value is negative 2. So f of negative 2 is negative 1/2. Negative 1/2. Do it again. F of next value, well, negative 1. So f of negative 1 is 1 divided by negative 1 is negative 1. Go to the next one. F of 1 over blank. Next one is 0. Now look up. This is 1 divided by 0. Could that be true? No, because remember, we can't have 0 in the denominator. Is that correct? So I want you to write here UND, which means undefined. Undefined. Because we cannot have this. Next, a 1. So f of 1 is 1. And f of 2 is 1/2. All right, let's graph this. All right, so we got negative 2 1/2. So I got 1, 2, negative 1, negative 2. And then these go all only up to 1. So I'm going to go 1, 2, 1, 2. Okay. Here we go. Negative 2, negative 1/2. Negative 2, negative 1/2. And then negative 1, negative 1. And check this out. I'm going to create one graph right here. Now I'm going to go undefined, meaning I don't have anything on 0. And I got 1, 1, 2 and 1/2. And do the other side. All right. So students, rational function students, we're about to get into that pretty soon. Just trying to give you a soft intro as to what it looks like. We good? Yeah? All right. Copy the agenda, please. Warm-up 38 done. Dividing polynomials. Get a Cornell note ready. You do need a Freire model. The box, please. Tonight's home play is play sheet 615C, numbers 1 through 8, evens only. Now, once again, I'm assuming, Mr. Q is assuming that your teachers did teach you how to do long division. Is that correct? Yes, Mr. Q, we love it. All right, good. So, today we're going to be doing that. So, copy the agenda. Once again, warm-up 38 done. Today we're going to be dividing polynomials. And tonight's home play, play sheet 6.5C, 1 through 8, evens only. Copy this code to access the home play. FE4Q3. Write that down, please. FE4Q3. 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 All right. All right. So this is how the home plate is going to look. Oh, yeah, we love these. And once again, if your code doesn't work, remind your neighbor where to go if the code doesn't work. Where do you go to get the home plate? Julian, where do we go? YouTube, yes. All right, get a Cornell note ready, please. There's the objective. You do need a Freire model. Set that up, please. All right, are we good? All right, thank you for sending that in. Appreciate it. Here we go. I can divide polynomials. So, tell your neighbor what concept we are on today. What concept are we going to be on today? Everyone. No, that's the objective. What is the concept for today? Polynomials. That is correct. And like I told my students when they first came to me, I'm telling you as well, from this point forward, you're not going to get away from polynomials. You're going to be walking down the street. You're going to be going to Donut Avenue to get your Arnold Palmer or whatever it is you buy there. Then you're going to hear in the alley, and they're going to go. You turn, and it's polynomial. They're going to be everywhere. You know what I'm saying? All right, here we go. What are polynomials? Write this down. Polynomials are expressions, monomials, or the sum or difference of monomials. Examples: 2x squared negative 3x to the fourth plus 2, x squared minus 3x plus 2. Non-examples, write these down, and the hashtags. The reason I'm going a little bit faster because we need to get to the practice, and I want to make sure that we got this. So copy that really quick. I'll give you some time, then I'll reiterate the definition. All right, here we go. Okay, look up, please. Writing utensils down. Let me break this down. So according to the definition, polynomials are monomials or the sum or difference of monomials. And some of you are like, what are monomials, Mr. Q? An expression with one part only. For example, look up. The number 2 by itself is only one part because there's nothing following it. X squared is one part, or it's known as a monomial. However, look at this one. How many parts does this one have? 2. Negative 3x fourth plus 2. This one, how many parts does it have? 3. 1, 2, 3. So, sum or difference of monomials. Addition or subtraction of monomials. See, there it is. However, for those of you that forgot, poly means many. Poly means what? And nomial means part. So that means polynomial means many parts. Yes. Non-examples. Tell your neighbor why these are not polynomials. Obviously, why are those not polynomials? Yeah, they're not expressions. What are they, people? They are equations, yes. So expressions do not have equal signs. Is that correct? Yeah, and expressions, we don't solve expressions. We just simplify expressions. That's where you wrote hashtag expressions only, various terms. Okay? So, types of division. Look up to the screen. Writing utensils down. Let's see. We have, how about 7 divided by 3? Yeah? Is the same as 7 divided by 3? Yes? Is the same as 7 divided by 3. You guys remember these? Yes? All right, here we go. Just in case you forgot. I'm going to go over long division. So, how do you work long division, Mr. Q? Well, you ask the question, what number times 3 gives us something close to 7? 2. So 2 times 3 is 6. Then what do? We subtract. Or in other words, this one we attach it to this one. So 7 minus 6 is 1. 1 is known as our what? Who remembers this R? What is this? Remainder, yes? So in case you forgot, here goes the names. This is called dividend. This one over here is called divisor. What was the answer to this division? This. The answer to the division is known as the quotient. And of course the R is called the what? Remainder. Remainder. Do you guys need to copy that? Do you guys need to copy it, or do you guys got it? All right. All right, copy it, please. I'll give you 1 minute. Just copy this part with all the terminology because I'm going to be using that throughout. Okay, we good? All right, so everybody has the terminology, yes? But Mr. Q, we're going to be doing this long division? Of course, but with polynomials. Let's go. Copy this one, please. Example 1. Divide using long division. Parentheses 3x cubed plus 22x squared plus 37x plus 10 divided by x plus 5. Copy that. All right? All right, here we go. Writing utensils down, look up to the screen. You all ready? All right, here it goes. I'm going to go over this step by step because this is where some of you get lost. I don't know why. This is fairly simple. Or in other words, this is squeezing. Not too easy, it's squeezy. So, here goes the process. Y'all ready? Step 1, look up to the screen. Check and see if the polynomials are in what standard form. Step 1, I'm going to check if they are in standard form. So let's see, what is the exponent on this variable? 3. So this is third degree. What is the exponent on this one? Second degree. What is the exponent on this one? 1. What is the exponent on this variable? There's no variable, so this is 0. Is it in standard form from highest to lowest? Yes, that's what we call standard form. So, with your pencil, mark that, please, on your paper to remind you that step 1 is standard form. As you're doing that, let's check the other one. Is this in first degree? This is 0 degree. Is it in standard form? Yes, from highest to lowest. Step 2. Focus. Step 2, write your long division. So, this is going to be our dividend. So we write 3x cubed plus 22x squared plus 37x plus 10 divided by x plus 5. If you have colored pens, use them because I'm going to be using different colors for each component. And step 3, divide. Here we go. I'm going to start with red. Look up to the screen. What number, I'm going to write the number over here on top, what number times x gives me 3x cubed? Think about it. Don't say it out loud. What number times x gives me 3x cubed? Talk it over to your neighbor. What number should I write up there that's going to multiply x to give me 3x cubed? All right. That number is what? 3x to the what? To the second. That is correct. Write that down. So here we go. 3x squared times x. Notice I'm multiplying this way. 3x squared times x is 3x cubed. However, this is a binomial. So now we multiply the 3x squared times the 5. What is 3x squared times 5? 15x squared. Everybody there? All right. Writing utensils down. Look up to the screen. Very important. Here it goes. Oh my goodness. Writing utensils down. Here it goes. What do I do next, Mr. Q? Well, I draw a line. I'm going to subtract, but before I do that, look up, please. I'm going to circle this and distribute that negative to both of these. Negative and negative. Why do I circle it here? So I won't forget to distribute to both terms. Why is that so important? Because watch. What is 3x cubed minus 3x cubed? Cancel. What is 22 minus 15? 7x squared. Copy that, please. All right, so let's see. Goes the process as you're finishing up copying that. What is the first thing we check for? Standard form for both polynomials. Were they in standard form from highest to lowest degree? Yes. Second, we write our division. So we get this polynomial, that's our dividend, divided by the divisor, which is x plus 5. From there, we start our division in red. And I said, what number times x gave me 3x cubed? We said 3x squared, so we multiply 3x squared times x, that's 3x cubed. But I said, since this is a binomial, 3x squared times 5 is 15, there it is. But then I said we subtract, so you won't forget to distribute. I want you to circle that and then distribute to both terms. This cancels, 22 minus 15 is 7, and we're there. From 1 to 5, I'll come to bar you up to right there. We good, yes? All right, very good. 10s and 5s. Next, bring down the next term. What is my next term? 37x, yes? So let's write it here, plus 37x. So, let's start all over again. Look up. Now I'm going to this spot. What number times x gives me 7x squared? Tell your neighbor, what number times x gives me 7x squared? Positive what? 7x. So 7x times x, that's 7x squared. However, 7x times 5 is what? 35x. Draw your line across, your subtraction. Before we forget, what do we do with that negative? We circle it and distribute that negative here and here. So 7x minus 7x cancel. 37 minus 35 is 2x. And we bring down the last term. What is my last term? Plus 10. So last but not least, what number, here it goes again, times x gives me 2x? Positive 2. So 2 times x is 2x. 2 times 5 is 10. We're going to subtract. And what do I said with that subtraction? You circle it, distribute this negative here and here. So what is 2x minus 2x? Cancel. 10 minus 10. So my remainder is what? 0. So, what is the answer to this division? What is the answer to this division? Everything on top, yes? 3x squared plus 7x plus 2. This is my quotient. Yes? From 1 to 5, how comfortable are you with this so far? Where are we at? 4 5s, 4 5s, okay. 2, okay. All right, send me that on your screen, please. I want to see what you did. All right. Thank you for sending that in. So, I did one with you, and as I mentioned, that was something that you should have done before. I'm just trying to bring it out. Copy this one, example 1Q. 10x cubed plus 31x squared plus x minus 6 equals, divided by x plus 3. I'm going to give you a head start and see if you can do this one by yourself. Follow the process that we just did on the previous one. Very similar. I'll give you some time, copy and go. All right. Let's see where we're at. For the sake of time, what is the first thing you check for? Standard form. Let's see. What is the degree on this one? 3. How about this one? 2. This one, 1. This one, 0. Is it in standard form? Yes. First degree, 0 degree. Is it in standard form? Yes. Step 2. Let's set it up. 10x cubed plus 31x squared plus x minus 6 divided by x plus 3. Hands if you set that up like that. All right, thank you. Next, what number times x gives us 10x cubed? Tell your neighbor. What number times x gives us 10x cubed? All right, looks like German's got it. So let's go with Carlos. What number times x gives us 10x cubed? 10x squared. That is correct. So 10x squared times x, 10x cubed. However, 10x squared times 3 is 30x squared. Subtraction. And what did I say with that subtraction? Circle it and do what? Distribute a negative here and there. So 10x cubed minus 10x cubed cancel. 31 minus 30 is 1x squared. Bring down, yes. Um, 31 minus 30 is 1, x squared. Yeah, when we add and subtract, we don't do anything to the exponents, only when we multiply. All right, from there we bring down the next term, which is plus x. So, start all over. What number times x gives me 1x squared? Tell your neighbor, and then German's going to enlighten us. What number times x gives me 1x squared? Tell your neighbor, please. What number times x gives us 1x squared? All right, German. What times x gives me 1x squared? X, that is correct. A positive x. So x times x is 1x squared. X times 3 is positive 3x. Subtract. What did I ask you to do? Circle that and distribute a negative here and there. These cancel. So what is 1x minus 3x? That's negative 2x. And bring down the last term. Negative 6. Tell your neighbor what number goes after the x up here in the answer. What number times x gives us negative 2x? Scarlett, what number times x gives us negative 2x? That is correct. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. Subtract. Look up. Circle this. Distribute the negative here, and it changes it to positive. Distribute the negative here, changes it to positive. So therefore, this cancels, so our remainder is 0. What is our answer, everyone, to this division? Our answer is 10x squared plus x minus 2. From 1 to 5, I'll come provide you with this so far. Where are we at? 3, 4, 5, couple 2s, 1.5. Some of you have weird fingers. All right, send that in, please. Send it to your screen. Once again, example 1, super Q, 12x cubed minus 19x squared minus 12x plus 4 divided by x minus 2. Copy that. I'll give you a head start and go. All right, not bad, not bad. Let's see. Process. Is it in standard form? Let's see. Third degree, second degree, first degree, 0 degree, yes. First degree, 0 degree, yes. From there, set up our division. 12x cubed minus 19x squared minus 12x plus 4 divided by our divisor, x minus 2. So, what number times x gives us 12x cubed? Let's go with the Hyman. 12x squared, that is correct. 12x squared times x is 12x cubed. 12x squared times negative 2 is negative 24x squared. What are we going to do? We're going to subtract. Look up, please. Make sure you write the subtraction somewhere to the left. You circle it, distribute here and here. So, this cancels. 24 minus 19 is 5x squared. Bring down the next term. What is my next term? 12x, and it's a negative. Start all over. What number times x gives us 5x squared? Positive what? 5x. 5x times x is 5x squared. 5x times negative 2 is negative 10x. Subtract. Circle it. Distribute here and here. This cancels. Negative 12 plus 10 is negative 2x. Bring down the last term, positive 4. Question, what number times x gives me negative 2x? Negative 2, so that is negative 2x. Negative 2 times negative 2 is positive 4. We're going to subtract. So, circle that, distribute here, changes to a positive, distribute here, changes to a negative. Cancels, cancels, and that leaves us with 0 remainder. What is our answer? Our answer is 12x squared plus 5x minus 2. Hands if you got that by yourself. Yeah, some of us. From 1 to 5, I'll come through you with this. All right, 4 5s for 5. So tonight, your home play is even numbers. Make sure you put some practice in. See you guys next time. Peace.